There it goes. Hi guys. Sorry, I was just waiting for the beat to know that it was recording. I hope you guys are having a great week. We're going into the first week of the very last quarter. I cannot believe we're already down to the last 10 weeks of this school year. It's definitely been a wild ride this school year, right? Everything's been a little crazy, but we've persevered and we've shown grit and we've worked our way through it. So we can definitely get through these next 10 weeks with definitely a lot of determination and with a lot of confidence that we can work through everything that we need to work through. So we are going to be working through 2 more lessons this week in Module 11. So we're going to do Module 11 Lesson 5 and Module 11 Lesson 6. So this first video is for Lesson 5. Next week we'll finish this module and then we'll begin a new one the following week. Okay, so we're going to get started. So I want you to have your Module 11 Lesson 5 out in front of you with a pencil so you can follow along. All right, I'll get my camera ready and we will begin. Okay. So we are going to be using common multiples to write equivalent fractions. And when we're talking about common multiples, we have our definition here. A common multiple is a number that is a multiple of 2 or more numbers. So when you think about multiples, you're thinking about numbers that can multiply together to equal, another. So, for example, the multiples of 4, I'm going to just skip down to this part before we read the problem so you can see what I'm talking about. When I'm talking about the multiples of 4, I'm thinking about all the numbers that can be multiplied with 4. Okay? So I would start with 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. So the first 5 multiples of 4 are 4, 8, 12, 16, 20. They're the first numbers when you're skip counting, right? When you're counting them, when you're multiplying by 4, the first 5. So we'll do that for 3 as well. So the first 5 multiples of 3, we have 3, 6, 9, 12, 15. Okay? So we're going to be able to use common multiples to rewrite 2 fractions so that they have a common denominator or a common numerator. And remember, the denominator, that's the number on the bottom. And the numerator, remember, that's the number on the top. So Sam needs 3/4 cup of bananas and a 2/3 cup of strawberries for a recipe. How can he write 3/4 and 2/3 as a pair of fractions with a common denominator? So here's where finding those common multiples is going to come into play. We need to think about the 4th and the 3rd, and we need to see what number would they have in common. What number would be an answer when you multiply the 4 by something and when you multiply the 3 by something? The answer would be the same. That's what they're talking about when they're talking about a common multiple. The same. So we already listed our multiples. And when I'm looking at our list of multiples, I'm hoping you can see, like I can see that, look at this. They have a 12 in common. So they both can get a 12 when we multiply. So we're going to choose our common multiple, which we just did. If we needed to, we could have listed more multiples to get to a common multiple, but we didn't need to. We were able to get to that multiple. So we're going to use multiplication to determine the relationship between each denominator and the common multiple we chose. So when I look at 4, what did I have to multiply by 4 to equal 12? Oops, sorry, down a little too low. What do I have to multiply by 4 to equal 12? I multiply 3 by 4 to equal 12. And then when I look at my 3, the denominator 3, what do I have to multiply by 3 to get to 12? Well, It's the inverse. Remember, we learned about that earlier. The inverse is when you can multiply 4 times 3 or 3 times 4. You're going to get the same answer, right, if you flip-flop them. So, by using the relationship between the denominators and the common multiple, we're going to write equivalent fractions. So remember, when we try to find an equivalent fraction, we have to multiply the top and the bottom by the same number. So when we have 3/4, we're looking at our denominator, which was the 4. So and we're trying to get to 12. So we're going to multiply the top and the bottom by 3. And remember, 3/3 is the same as 1 whole. That's why this works, because when you multiply anything by 1, it's going to equal itself, right? That's the identity property. So this just gives us a fraction that has a common denominator, so we can find equivalent fractions. So 3 times 3 is 9. 3 times 4 is 12. So 3/4 is equivalent to 9/12. So let's look at our denominator here. Remember, we're going to multiply it by 4 because we want to get that common denominator of 12. So we're going to multiply it by 4 over 4. And again, 4/4 is the same as 1 whole. That's why this works, because 1 whole, anything times 1 is itself, gives us our equivalent fraction. 4 times 2 is 8. 4 times 3 is 12. So 2/3 is equivalent to 8/12. Now, if I'm looking at these two fractions, now I want to compare them. I know this isn't a question, but I'm just thinking ahead. Probably that's what we're going to be working towards eventually. So let's look at these two. Which one is bigger? Well, that would be 3/4 is bigger than 2/3, because 3/4 is equivalent to 9/12 and 2/3 is equivalent to 8/12. So they're super close. They're only 1/12 difference, but 3/4 would be just a little bit bigger than 2/3, and they're common and they're equivalent fractions. Okay. So next page, 284. We're gonna step it out. Allison needs 5/8 cup of almonds and 4/5 cup of walnuts for a recipe. How can she write 5/8 and 4/5 as a pair of fractions with a common denominator? So again, we're going to find a common multiple that can be used as a common numerator. So this time we're doing the numerator. So I need to look at the top number. So I need to look at the 4 and the 5, not the 8 and the 5, the 4 and the 5. So let's list the first 5 multiples of 5. So we would have 5, 10, 15, 20, 25. First 5 multiples of 4. 4, 8, 12, 16, 20. So did we find a number that they have in common? They have a 20 in common, right? And how we got to 20 with our 5, with our numerator of 5, we would have multiplied 5 times 4, right? 1, 2, 3, 4 is the fourth one, equals 20. And for 4, we would have to multiply by the 1, 2, 3, 4, fifth one. 4 times 5 equals 20. So notice for these two problems we've done, we've just used the opposite number, or the number from the other fraction. So 5 times 4 is 20. 4 times 5 is 20. So we're going to use this relationship between the numerators and the common multiple to write our equivalent fractions. So we're with our 5, so we need to have this multiplied by 4 over 4. 4 times 5 is 20. 4 times 8 is, I'm giving you a minute to think, 32. Now over here, remember we're finding common numerator, so we need to use the 5/5. 5 times 4 is 20. 5 times 5 is 25. So which one of these fractions has bigger pieces? The bigger pieces would be here, right? Because you only have 25 of them. If I had a cake, a really large cake for a party, and I cut it into 25 pieces, you're going to get a bigger piece of the cake over here than you will if I cut the cake into 32 pieces, right? Because 32 would be smaller pieces because I would need to get more pieces out of that cake. So that tells me that 20 25ths is going to be greater than 20 32s because I have bigger pieces. Even though I'm going to have the same number of pieces, my pieces are bigger over here than they are over here. So that's the trick to be thinking about. When we're looking where we have a common numerator, we're going to look at the size of our pieces. Which ones are bigger and which ones are smaller? How many pieces did they break it up into? The smaller number for the denominator means a bigger piece. When we find a common denominator, then we're going to look at the numerator, and whichever one is bigger, that means you're going to have more of that many, or of that item. So that's the thought process. That's what you've got to be thinking. Numerator is how many pieces you have. Denominator is the size of the pieces. Okay? Alrighty. So we're going to write a pair of fractions with a common denominator or a common numerator. We get to choose. So why don't we do the first one with a common denominator? Okay, we're going to start with our denominator. We're going to start with our 3 and our 5. So if I think about my 3s and my 5s, if I count by 3, 6, 9, 12, 15, and I count by 5s, 5, 10, 15, you know what? I don't need to go any further, do I? Because look at, there's what they have in common is a 15. So if I multiply 1/3 times 5/5, I will get 5/15. Sorry, I'm trying to get this so you can see it a little bit bigger. The camera's in an odd angle. It's even more odd. Sorry about that. And then this one we would multiply by 3/3. So 2/5 times 3/3, and I'm going to put the equals just so that they're next to each other. 3 times 2 is 6. 3 times 5 is 15. So an equivalent fraction for 1/3 is 5/15. An equivalent fraction for 2/5 is 6/15. So which one is bigger? The 6/15 would be bigger because we have more, right? We have more of them. They're both cut in the same size. They're both cut into 15ths. So I'm going to have 6 of them here. I want to have 6, right? If I have a candy bar, right, I want 6/15 more than 5/15 if I like that candy bar. All right, how about we do this one with a common numerator? Oh, look, it's the same numbers. 3 and 5. So that should help us out a lot, right? So if I have, so I already know I'm going to need to multiply it by 5/5 because if I paid attention to what I did last time, right? Times 3/4. So 5 times 3 is 15. 5 times 4 is 20. And then for this one, I'm going to do 5/8 times 3/3 because I want that common numerator this time. So 3 times 5 is 15. 3 times 8 is 24. So I'm going to get 15 pieces for either one. So here's I'm going to circle my answers. Sorry, that's like super tiny. I should have made it a little bit bigger. It's not working very well for me. Oh, maybe if let me try this. Oh, that's better. Sorry about that. I should have thought about that earlier. So this is broken up into more pieces than this. So that means 15/20ths are going to be the bigger pieces. So you would get bigger pieces here than you are getting here. You're going to get 15 either way, but the pieces will be bigger if they're in 20ths than if they're in 24ths. Okay? And our last one, we have 2/5 and 3/8. So why don't we do our denominator again? So if I think about my 5 and my 8, notice what we've been doing, right? We've been basically taking the opposite and multiplying it together. So let's do that with this one. So let's do 8/8. We're going to take the opposite denominator times 2/5, and that's going to equal 16/40ths. And if I take 3/8 and I'm going to multiply it by the opposite denominator, so 5/5, that's going to equal 15/40ths. Oh, look at how close these two fractions are. They're only 1/40th from one another. So 2/5 is just a little bit bigger than 3/8. Okay? All right, so now we're going to move to the on your own section. Now remember, when we get to this part, if you choose to do it independently, that is perfectly fine. If you want to stay right with me, that is great as well. You choose whichever you feel the most comfortable doing. So Jerry has two same-sized circles divided into the same number of equal parts. One circle has 3/4 of the parts shaded, and the other has 2/3 of the parts shaded. His sister says the least common pieces each circle could be divided into is 7. Is his sister correct? Well, let's look at this. If we have 3/4 and we have 2/3, I think I know what his sister did. I think his sister added instead of multiplied, right? And we don't add denominators. So, is his sister correct? No. Because let's do the work out so we can show why. Because when we explain, we just need to show what work we would have to do. So if I took I'm going to do it with denominators because that's what she did, right? The least number of pieces each circle could be divided into is 7. So that's the denominator, the pieces it's divided into. So let's 3/4. We're going to multiply by the opposite denominator, 3/3. So I get 9/12. And then I'm going to take my 2/3, multiply it by the opposite denominator, which is 4/4, and I get 8/12. So the denominator would be 12ths, not 7ths. So the least number of pieces a circle could be divided into is actually 12. So the least number of pieces the circle could be divided into is 12, not 7. So that's why his sister is incorrect. Because again, it looks to me like she must have added those two, and that is not how we find common denominators. No, we never add it. Not the denominators anyway. All right. Megara was working on her math homework when she spilled orange juice on her paper. She wrote 2 pairs of equivalent fractions. What is the unknown numerator covered by the juice? All right, so let's see. What did she do? So let's see what she did. For this fraction, she multiplied, what would she have multiplied the top and the bottom by? She would have multiplied the top and the bottom by 2/2, right? So this fraction up here, what did she multiply the top and the bottom by? Well, 6 times what equals 24? 6 times 4 equals 24. So what times 4 must equal 8? Well, that would be 2. 2 times 4 equals 8. So the unknown numerator is 2. Okay. Write the pair of fractions as a pair of fractions with a common denominator. So we're looking at the bottom number. So let's look at our 4 and our 6. So one way we could do this is we could list our denominator, or our numbers, right, that they have in common, or we could multiply by the opposite denominator. Either way works. I'm going to show you both ways. One thing I know about 4 and 6, I know that if I count by 4s, 4, 8, 12, and if I count by 6, 6, 12, they both have a 12 in common. So one way I could do this is I could multiply 1/4 times 3 over 3, because that's how I'm going to get my 12 at the denominator. 3 times 1 is 3. 3 times 4 is 12. And then my 5, 6, I could multiply by 2 over 2. That's what's going to get me my 12ths at the bottom. So 5 times 2 is 10. 6 times 2 is 12. 10 twelfths. So that's one way we could do this, right? Is to find that common denominator. The other way we could do this is to multiply by the opposite fraction, the opposite denominator. So we could do 1/4 times 6 over 6, right? Because that's the opposite denominator. And that would give us 6 24ths. And we could multiply 5, 6 times 4 over 4, and that would give us 20 24ths. So those are the two different ways. They both give us a common denominator, right? That's what we're after. That's what we're looking for. So either way, these are going to be correct, right? Either way. This is just the smallest number of pieces you could break them both up into. And that would be the next smallest, right? We'd have to go bigger. Okay? So these two are our common denominators again. So one thing I'm noticing is the 5 and the 10. If I look at these two numbers, I know that if I count by 5s, look at that, I get a 10. I don't need to do anything to my 4/10. So I could have 2 over 2 times 3/5, and that's going to give me 6/10. So I would have 6/10 and 4/10. The other thing, remember, we can multiply by the opposite denominator. So 3/5 times 10 over 10 would give us 30 50ths. And then 4/10 times 5 over 5 is going to give us 20 50ths. Either way, I'm finding a common denominator. You choose which way you feel the most comfortable. Okay, now we're going to find fractions with a common numerator, so that top number. So here we have a 1 and a 5. So I know 1 and 5, let's see. The nice thing about 1 is it would have any number in common, right? So all I would need to do is multiply our 1/6 by 5 over 5, and that's going to give us 5 30ths and 5 8ths. We don't need to do anything to the 5 8ths because this was a 1, so we just need, remember, we're finding the common numerator, common numerator. So we didn't necessarily have to do anything because now they have a common numerator. Let's look over here. We have a 2 and we have a 5. Well, the only thing I know how to do for this one, I can't think of anything they have in common other than multiplying by each other. So if I have 2/3 times 5/5, I'm going to have 10 15ths. And if I have 5 6 multiplied by 2 halves, I'm going to have 10 twelfths. So that would have our common numerator. Okay, and the last page. Find a common denominator for the pair of fractions. So again, a common denominator. So if I have 5 and 8, what do they have in common? Well, they would have, remember we're doing denominator, they would have 40 in common because I can multiply them by each other. So if I multiply 1/5 times 8 over 8, I would have 8/40ths. And if I multiply 1/8 times 5 over 5, I would have 5/40ths. So the common denominator would be 40. Well, I guess I just needed to write the 40. Sorry about that. You can do this too. Okay. Common denominator for 5 and 2. That would be 10. Because I would multiply it by 2 over 2. So I would have 4/10. And 5 over 5 would be 5/10. Common denominator here, we could do 12. Remember we did 4 and 6 before. We could have 12 as our common denominator because I would multiply this by 3 over 3, which would be 6/12. And this I would multiply by 2 over 2, which would be 10/12. But if you chose to multiply it by each other, it would be 24. Alrighty. Nicholas wants to rewrite 3/5 and 6/12 so they have either the same numerator or the same denominator. Should he use a common numerator or a common denominator? Well, either way would work well. But if I look at our numerators, 3 and 6, I'm not going to have to do as much work for, right? I'm only going to have to multiply one of my fractions. Whereas 5 and 12, they don't really have anything in common until you get up to the number 60. So 3 and 6, if I look at 3/5, I would multiply that by 2 over 2, which would give me 6/10. And then I have 6/12. So finding a common numerator would be easier. Because we can see that 3 and 6 have something in common, right? That's what we're looking for, is commonality. Alrighty. So rewrite the fractions so they have a common numerator or denominator. We get to choose again what we think would be best. So we have 6/8 and we have 2/3. What do we think would be the best common numerator or denominator? Well, if I think about my numerators, I have a 6 here and I have a 2 here. Doesn't the 2 have something in common with 6? Couldn't I multiply my 2/3 by 3 over 3? And that's going to give me 6/9. So then they would have a common numerator. So I would have 6/9 and 6/8. Okay, number 15. Mare paints equal sections of a wall to make a pattern. She paints 2/5 of the wall white and 1/2 of the wall lavender. So how about we do denominators this time? So we would just multiply by the opposite denominator. So 2/5 times 2 over 2 equals 4/10. And 1/2 times 5 over 5 equals 5/10. So that would be our 2 with the same denominator. You could do the same numerator too, because 1/2 you could be 2/4, and then that would be, one less that you'd have to do. So if that's what you did, that works as well. Koji says to find a common denominator for any two fractions, you just need to multiply the two denominators of the fractions. Do you agree? Well, remember, you could just, take the denominators and multiply it by the opposite denominator, and that would get you common or equivalent fractions. So yes, ... when you multiply the opposite denominators, you will get equivalent fractions. All right. Okay, so I need you to do the black and white independent worksheet, the more practice / homework 11.5. You're going to do the front and the back. Kane, I sent you a different sheet to do, so I would like you to do that one with a lot less words on it, a lot less word problems. So please do the worksheets that were provided to each group, and then get them back to me in school by the end of the week. All right, have a great rest of your day. Bye.